Okay, Rich, we're trying something new on the pod.
What are we doing? Are we tinkering, dude?
Yeah, we're hacking.
Okay.
We're hacking a little bit. I feel like we both hack on so many things in our spare time, and you really don't get the opportunity to showcase it.
I want to see it, dude.
We're working independent. We don't have all hands presentations. We can't really flex.
That's
So
true.
I'm thinking we have a couple of YouTube shorts where we just talk about what we're doing, keep it super casual and organic, and we see if we like it.
Well, let's see what this Waymark thing is about, shall we?
So peep this. I'm actually pretty excited about this. I've been working on this for a little while now. And basically, are you familiar with these like durable execution frameworks like Temporal,
Sure.
Vercel workflows? They just announced one. It's basically this idea.
Oh, Vercel has one too?
Yeah, they just announced one for JavaScript.
Okay.
Type. The idea with all of them is basically the same. I think like Temporal were the first guys to really pull this off and like, make this ubiquitous. But it's kind of this idea that every web app, every application is probably going to have to do some things in the background. It's things that you want to run on some periodic schedule, or you want it to not be blocking on some front end task. And you often only want to run some of those commands one time.
One and done.
So if we actually think of one example of what Temporal and like Temporal-like things are doing for durable executions, if we're trying to send some group of users an email, you can kind of detach this run or flow logic of what we want it to do from the actual things that make this happen.
Yeah.
Where in this case, we're describing like, okay, we have a list of users. We want to get their metadata. We want to see if they're currently active on the platform. And then we want to send an individual email to all of them.
Yeah.
And if this was just in some body, in some like post endpoint on your web app, if a server crashes halfway through, this could be really bad. Because if you're having to replay this completely from scratch, you might send 2 emails to the first half of this list that you were able to get through.
No bueno.
That's what we call in the industry.
No bueno.
Bueno situation.
That's right.
So the thinking with these like durable execution things is we write the commands that we want to do that might be risky into separate actions. And those can be cached once they're executed. So we only ever run them once. So like I mentioned, Temporal does this, Vercel does this, but all of them thus far have basically operated where you have to keep running the workflow orchestration in an interpreter. So even if you're like booting it up again, you have to trace through every line of code to get back to the state when the program was interrupted the first time.
Okay.
So again, like if server crashes, you boot it back up again, it has to go through all these lines until it gets to the point where something is net new.
Gotcha.
That's not like that big of a deal if you're only doing that one time. But as things get more complicated and you have to go through more lines of code, like you're kind of just burning compute unnecessarily. And nobody likes that. I kind of have been playing around for a while now of like, what if we could design a programming language which is built for this parallel situation and has specific language constructs for doing these parallel tasks?
If only, dude.
If only. Hypothetically.
If only.
Coming to an interpreter near you soon. Waymark actually has that. So what's kind of sick here is that behind the scenes, because of this workflow decorator, we parse the abstract syntax tree of the code that we have in run and then map that on to our language. So it's kind of this like runtime pass where we're literally inspecting the code and transforming it into our primitives. So in the back end, you're like, okay, we call this action because we were able to identify that fetch users is an action.
Yeah.
It provides this filtering mechanism, which breaks apart into basically like a for loop aggregator over a list. And then within this gather, this would just be like a spread, where we have this list, we want to execute these actions on top of it. So we can like spread over this thing and then return the results. And that's all a separate language that then lets us do something kind of sick, which is compile it into a graph.
Whoa.
Where you can convert that whole thing that we just wrote basically so that each node is message passing to some other nodes, which like roughly follows how you actually write that line by line.
Mm-hmm.
But each of these nodes can track state of where we are. So you're kind of like turning this run function that you wrote in your original language into this IR so that we can turn it into a state machine that we can then iterate on. So at any point when you're executing this thing, we're at this node. We're at like node 4. And the nice thing is, if you can just remember that you're at node 4, even if the program stops, if it starts up again, you can skip through all of nodes 1 through 4. You can just start at node 4 and then continue forward from node 4. So anyway, this Waymark just operates kind of under this graph construct, which then lets it be trivially parallelized across all CPU cores when it's running. Because it's no longer bound to this interpreter. it can be written and run in this Rust core that is just executing these graphs dynamically, figuring out what actions it has to run, and then passing those off to a cluster of Python workers, which are actually doing that work.
Let's say it like crashes at the await to send the email, right?
Mhm.
It's gotten everything.
Yeah.
So then in Rust, it knows, hey, this was the last action I should have run. Let me then basically spin up a Python interpreter.
No. So it doesn't have to do that, which is like
Oh, wow.
kind of the nice thing, is because at each step here, we're modifying this graph to include some metadata that, yes, we've kicked this off, / like, yes, it's complete.
Gotcha.
So we basically have these check marks at every time before we actually try to do that work to know that we have attempted to start the work.
I see.
So it's like in this case, walking through,
Yep.
it starts off, recognizes, hey, it has to call this action. So it marks this as pending, right?
Yep.
And then sends the actual function itself into a Python interpreter.
Gotcha.
So it can run with all the context of your library, your app, your helper functions, gets back the results from the database. Once that is done, it sends back to Rust. Rust gets a result from the pool, is like, amazing, done. I'm
Mhm.
going to save the results into the database to say, okay, yes, we have some persistent store, wait for that to be done. And that includes both the signal of like where we are on the DAG and also what the results of this Python function call are. And then it's like, all right, next thing we do in the Rust runtime is do this filter, which we can do without calling Python at all. We then get this list of active users, and then we see that the next thing is to spawn a bunch of these actions. Sweet, no problem. We can mark these as queued. Again, send them to the action worker.
Yep.
And then these, as they iteratively come back, we're then saving. So let's say this is like separate things,
Yep.
queued.
Yep.
You can change one to be done.
Yep.
And then if it crashes, no problem. We can just replay it knowing that it's done and it's at this part of the graph.
Yep.
And we just have to either wait for this to be queued to be done, or in the case where the whole thing crashed, we'll just re-queue it ×2, rerun it, get it done, and then no harm, no foul.
Yep. Makes
'cause
sense.
It never actually made
It's awesome.
progress. And it's all kind of facilitated by this graph layer that's in the middle in Rust, which also means that you can extend it to any other client-side language that's beyond Python. All you have to do is just walk the AST, build like a little compiler to just convert it to the intermediate representation, and then boom, it can plug and play with the same infra that we have in Rust because it's no longer within the original like workflow definition language.
Let's say you had the identical code written in Python and JavaScript. Would it be the same AST for JavaScript and Python, or is that a little bit language dependent?
I think it would basically be the same thing.
Do you have to build a special tool for each client-facing language to generate the AST?
Yeah. And I think there's like some nuances in that
Yeah.
because each language has like different runtime
Yeah.
guarantees with the
Yeah.
AST. Like Python, you can inspect it all at runtime, which is pretty convenient. JavaScript, usually you're piping through a builder or a compiler layer, which might be transparent. It's like Node.js is bundled with TurboPack usually, which like kind of takes care of this behind the scenes. Rust, you have access to the build time via macros. So you can just add a macro that serializes some of this AST. You can kind of do the same thing in Golang. So I think there's some nuances with like cross-language extraction of this, but usually some combination like at build time or at runtime, you can get the AST. And then if you save it into this IR, we can just pull from that at runtime.
That's awesome, man. And what are you going to use this for?
Literally all my backend.
Literally everything.
Well, I mean, like
You may as well, right?
I built it. Might as well. But like,
Yeah.
I specifically built this because I was using Temporal at Say What to handle all our backend orchestrations. And the way that their cloud hosting works, this was like 6 months ago, maybe a year before I started this project, and our bills in the cloud were getting up to $8,000 a month just to host this coordination service. And like, they're not even dealing with the compute for the work. They're literally just like handling the sending of commands to our servers to be like, hey, here's a job you need to do now. Let me take the result value, do something. So this has already dropped our costs from the $8,000 to like $50 a month just to maintain these backend worker pools. And like the paradigm I like I think durable execution as like a layer in your backend makes everything so much simpler to reason about, because my default at this point is any complicated work that has to happen when a user is not directly in the loop, or that I'm like worried that it might crash at some inconsistent state and that would be bad. I literally just put in one of these backend workflows and then let it run.
That's awesome.
And it's also fully interpretable, which is kind of sick too. Like I can actually boot up an example app to maybe show this thing in practice. And while this is building, unlike when you're just in some runtime and you're like, oh, how is my Python running?
Yep.
You can kind of like introspect the outputs of like, what data has this created, or are there some checkpoint enums? But it's kind of opaque to you, or you can look at logs, right? I guess is like the main thing. Once the service is actually running, the nice thing about checkpointing things in the back end is you can then see exactly what returned from each of these function calls and use that to debug the system. So like any crashes, any failures, it doesn't just wind up in like Sentry or like log reporting.
Yep.
You can actually be like, oh, okay, well, this failed. And then that cascaded to this
Down
other
to
thing
this.
that proceeded
Right.
to fail. Yeah,
Right.
totally. All right. So take a gander at this, Rich.
Let's take a look.
This is the example app. So this is just all of these workflows that are coded in the backend. You know what I mean? It's like, here's a parallel, async IO gather. Okay, great. We run the parallel. Great, it works.
Ooh, it works.
A sequential chain. Oh, dude, it works. An if then or an if else, it works. But the thing that I did want to show you is behind the scenes, you can visualize all of these, which I think is actually kind of cool. Okay, yes, there are these two compute factorial and then compute Fibonacci calls. They were kicked off at the same time, but the factorial took longer by, I guess, 9 milliseconds than this compute Fibonacci. And then when that's done, that summarizes the math. And then you can expand these to be like, okay, what request did we send in this function? What result did we get back? And then it finally gives you this eventual payload, which is the summary of which one is greater. And you can do that for every one of these. You can do sequential chain, uppercase, reverse, see it on the timeline. So it's really become my default way to implement these programs in the backend. It's like totally interpretable. You can replay it. You can have the web app. And that's the take, man.
This is great, dude.
It's basically the 10-minute pitch.
I'm excited to see what you build with it.
Me too.
You always inspire me to tinker more with my own stuff. I think I'll give this a little whirl.
Yeah, do it. Add it to the Pico backend, which maybe we can feature in the next episode.
I would love to, dude. This is so cool. Well, shout out to Waymark. Let's see if anyone on the pre-train pod might want to be an early adopter.
Yeah. Like and subscribe.
Like and subscribe, baby.
Okay. Well, till next time, Rich.
See ya.
Later.
Bye.